Hi everyone, this is Mrs. Paglione here. We're working on week 4 for pre-algebra. We are going to talk about polygons and different types of polygons or things that maybe aren't polygons. We are going to name different types of polygons all the way up to 10. And then we are going to work on focusing on four-sided polygons, so quadrilaterals. But let's start with polygons. So take a moment and fill out this definition. A polygon is a closed figure whose sides are segments, meaning that they're lines, meaning that they're straight, and they intersect at their endpoints. A regular polygon is when you have all sides that are going to be marked congruent or the same length, and all angles are going to be the same length as well. So we have 3 different columns here. The first column, this column right here, these are all polygons. All their sides are straight and they all connect. Whereas in the middle, you start seeing all these different markings. So you see angles that are the same and then these congruency marks for the sides. Those would be our regular polygons. Regular polygons. So they're polygons. They just have a special conditions where all their angles and their sides are the same. Here, these are not polygons. Okay, so these are not polygons. So these, you can tell you've got a big opening right there. This is a curved line, so that's no good. And that these are intersecting each other, so you don't want segments that cross over each other. So those are not polygons. Now the difference between convex and concave. So a convex polygon is when you have all of the segments are on the outside. So a convex polygon, a polygon is convex if a segment joining any 2 interior points lies completely within the polygon. A polygon is concave, hence the word cave, if it has a dent or cave in it. So that would be like right here. If I was to connect these 2 points right there, I would have a little bit of a cave in there. So that would be a concave polygon. All right, naming polygons. So a 3-sided polygon is a triangle. A 4-sided polygon is a quadrilateral, which we're going to focus on a little bit more towards the ends of our notes. A 5-sided is a pentagon. 6-sided is a hexagon. 7-sided is a hep with a P, tagon. 8-sided is an octagon. 9 is a nonagon. 10 is a decagon. More than 10 would just be whatever the number is, then the word gon. So a 12-gon, a 13-gon, a 14-gon, whatever it may be. All right, for the next section, we're going to tell whether the figure is a polygon. If the figure is a polygon, we're going to name it based on the number of sides, decide if it's regular or not, and decide if it's convex or concave. If it's not a polygon, we're actually going to jump right to the last column and tell me why it's not a polygon. So the first one, this circle is not a polygon. So I'm not going to actually answer any of the middle 3. It's not a polygon because it's a circle. Okay, the lines aren't straight, so the sides are not straight. For the next one, this is a polygon. Yes, it is a polygon. It has 1, 2, 3, 4, 5 sides. So a 5-sided polygon is called a pentagon. Is it regular? No, it's not regular. I marked the sides up, but you can see that the angles and the sides are not equal in length, so it's not going to work. So this is going to be called this is going to be regular, or not regular. And then it's concave. Do you see kind of how you have a cave here where it jets in? That makes it concave. And then I don't need to answer the last one. All right, the next one. Yes, this is a polygon. It has 1, 2, 3, 4, 5, 6 sides. So it's a hexagon. And yes, it is regular. And the reason why it's regular is you can see that all the angles are marked and all the sides are marked to be congruent. This is convex because nothing jets in to make a cave, and then I don't need to answer the last one. Number 4, no, this is not a polygon. So I can't name it, decide if it's regular or convex. It's not a polygon because it's open. Okay, do you see how you have this big gaping hole right there? That's open, which means it's not a polygon. All right, here is some algebra. So here's some math. So an interior angle is an angle that lies inside the polygon. All right, so I'm going to mark that in pink. These are all my interior angles. Where in green are my exterior angles. So the exterior angles are actually going to come out on the outside, which we're going to talk about very soon. Sum of the interior angles is the sum of all the interior angles added together. So some of this you might know. So a triangle we know has to add to 180, but we might not know what about a decagon or a nonagon or a hexagon. So there's actually a formula that we can use. So how to find the sum of the interior angles of a convex polygon is n minus 2 times 180, where n is the number of sides. Okay, however many number of sides you have, minus 2 times 180. So you take the number of sides you have, you subtract 2, and then you multiply by 180. So my first one is a quadrilateral. So you can go back up to the chart if you need to see how many sides are in a quadrilateral, but a quadrilateral is 4. So I would take my 4 sides, I would subtract 2, and then multiply by 180. PEMDAS says I have to do that first, so 2 times 180 is 360 degrees. So all the angles inside of a quadrilateral, a 4-sided polygon, so my n would equal 4, is 360. Here I can count up the sides, 1, 2, 3, 4, 5, 6, 7, 8, so my n is 8. So 8 minus 2 times 180 is 6 times 180. So I can go to my calculator here, do 6 times 180, and that's going to give me 1,080 degrees. Okay, so all of these angles, every single angle, I'll mark them in pink. This angle plus this angle plus this angle, this angle, this angle, this angle, all added together have to equal 1,080 degrees. Now, if I just want to find one angle, so instead of the sum, I just want to find out what one of the angle measurements are, what you would do is you would use your n minus 2 times 180, whatever the sum is, but then you would do the last step and divide by the number of sides. So up here, if this was regular, to find out what one angle measurement is, I would divide this by 8. So if I divide it by 8, it tells me 135 degrees is the measure of every single angle. Okay, but it only works for regular polygons. So here's a perfect example. So I have an example right here. Let's count the number of sides. 1, 2, 3, 4, 5, 6. So n is 6. So I'm going to find the sum first by doing 6 minus 2 times 180. And then I'm going to divide it by the number of sides I have, which is 6. So that's 4 times 180 divided by 6. 4 times 180 is 720. 720 divided by 6 tells me that every single angle is going to be 120 degrees. So this angle is 120, this angle is 120, this angle, and so on. They're all 120 degrees. Next one is a nonagon. So a nonagon means that my side measures are 9. So I would do 9 minus 2 times 180, but then divide by 9 because they want 1 in the directions. It says 1 interior. So anytime they say they want 1, you have to divide. So 9 minus 2 is 7. 7 times 180 gives me the numerator of 1,260, and then I divide that by 9. Divide by 9, I get 140 degrees. So in this nonagon, all 9 of the angles would be 140 degrees. An exterior angle is an angle on the outside of the polygon. Okay, it's on the outside. I know that's a kind of a strange concept, but for any and all polygons, the sum is always going to be the same, and the sum is always 360 degrees. So that's the nice part. They can't ask you for the sum because it's always going to be the same. It's always going to be 360, but they can ask us for 1. So you would have to do 360 divided by the number of sides you have. So that's for the exterior angles, okay? You would do 360 divided by the number of sides. So a square has 4 sides. I want one exterior, so that's 360 divided by 4. I could put that in my calculator, but it's 90 degrees. So all my exterior angles are 90 degrees. Hexagon is 6, so I'd be doing 360 divided by 6, which is 60 degrees. Okay, for the second part of the notes, we are going to just focus on quadrilaterals. So quadrilaterals are a polygon with 4 sides. So we're just focusing on the 4 sides. And you can call it a quadrilateral, but when you think about 4 sides, you guys might be thinking about squares and rectangles and rhombuses, or rhombi is the plural word for that, or a trapezoid or a kite. So we're actually going to go through and talk about those using this flow chart. So first, fill out a quadrilateral. So the top one is a quadrilateral. It just has 4 sides. So every figure I'm going to give you from here on out is going to be a 4-sided figure, so it's going to be able to be called a quadrilateral. From there, you've got the trapezoid. So a trapezoid only has 1 pair of parallel sides, and I'm going to mark them. What color do I want to use? Let's use blue. And that's going to be your top side and your bottom side. So those are going to be the only ones that are parallel, not the left and the right. You can see that eventually if I extend these out, they're going to touch each other. So it's not the left and the right, it's just the top and the bottom. Then over here, I have a parallelogram. So a parallelogram is when 2 things happen. Opposite sides are going to be parallel to each other. So the top is going to be parallel to the bottom, and the right is going to be parallel to the left. Also, opposite sides are congruent. So if this side is marked with a congruency mark, this side is also going to be marked. So if this is like 5 inches, this is also going to be 5 inches. And then the top is going to be the same as the bottom. So they're probably going to have different marks. So if the top was 10 inches, the bottom would be 10 inches. Then from there, you have a rectangle. So rectangles are pretty common. Opposite sides are going to be parallel and congruent. So you're going to see these markings for the parallel. Okay. You're also going to see opposite sides are equal to each other. Okay. So top and bottom, left and right are equal. And you're also going to see 4 right angles. Okay. A rhombus is very similar, where the top is going to be parallel to the bottom, the right is going to be parallel to the left, but this one, all of the sides are the same. So that's a little bit different. So this is going to be 4 inches, and this is going to be 4 inches, and this one, and this one. And then the last one you have is a square. So a square has opposite sides parallel, so I'll draw that down for us. Opposite sides are parallel. You have 4 right angles, and all the side measures are going to be exactly the same. So this will be like 5 inches, 5 inches, and same thing the whole way around. So if I go down to my examples, they want me to classify these in as many ways as possible. So for the first one, everything's going to be a quadrilateral. No matter what, they're all going to be quads because they all have 4 sides. So I'm actually just going to write that one down. They're all quads because they're all 4 sides. Okay, so they're all going to be quadrilaterals. But for this one, I only have 1 pair of parallel sides. 1 pair of parallel sides means it's a trapezoid right here. Okay, the top and the bottom are parallel. So I'm going to write trapezoid. And that's the only other way that I can classify that. And the best classification would be trapezoid. Okay, that would be the best thing for you to call it. So on your IXL, you'd want to call this a trapezoid if they were asking you. All right, the next one. I see that I've got opposite sides are going to be parallel to each other. Well, I see basically this is a square. Okay, that's what I see. I see that this is a square because I've got 4 right angles and I've got all the sides equal. Well, a square is actually a rectangle and it's actually a parallelogram. So it gets all of the names. So it's a parallelogram and it's a rectangle, which is pretty cool. But the best name is that it's a square. All right, move on to the second video and we can finish up these notes.